There are three main right angle triangles that provide us with the special angles and 6 trigonometric ratios. Using these special triangles, we can solve trig equations and simplify trig expressions that use 45 degrees, 60 degrees, 30 degrees, 0, or 90 degrees, and any modified version in other quadrants. So the first special triangle that we have is an isosceles triangle that has a right angle, making the two equal angles both 45 degrees. Now we have the option to pick the size of the two sides that are equal. And to make our life a little easier, I'm going to make them both 1. So those two sides are both 1, and the only side that we're missing is the hypotenuse. And we can solve for the hypotenuse using Pythagorean theorem. So 1 squared plus 1 squared equals x squared. So that would give us 1 plus 1, which is 2. And when we square root both sides, we get plus or minus the square root of 2. And because this is a dimension of a triangle, we are just going to use the positive version for our hypotenuse. So there's our first special triangle. Isosceles, the two angles are 45, two of the sides are 1, and the hypotenuse is the square root of 2. Now, this is something, as long as you remember it's an isosceles triangle, even if you forget that the two equal sides are 1 and use 2 or 3, when you set up your ratios, it will still simplify to the same value. Just using 1 is the easiest and most simple form. So let's go ahead and find those 6 trig ratios for the 45 degree angle. Now I'm going to use this bottom 45 as my reference angle. It obviously wouldn't make a difference because it is isosceles. And I'm going to label opposite, adjacent, and hypotenuse. And now let's go ahead and write our trig ratios. So sine 45 is going to be opposite over hypotenuse, which is 1 over root 2. I don't want a radical in the denominator, so I'm going to multiply top and bottom by root 2. And when I do that, I end up with root 2 in the numerator and a whole number of 2 in the denominator. Now let's go ahead and do cos theta. Cos 45 is adjacent over hypotenuse, which is also 1 over root 2, which simplifies to root 2 over 2. Tan is opposite over adjacent, so 1 over 1, which is just 1. Cosecant is the reciprocal of sine. So I'm going to go to my unrationalized fraction where the radical is in the denominator, because when I take the reciprocal, this root 2 in the denominator will go up into the numerator. So we're going to get root 2 over 1, which is just root 2. And same thing with the reciprocal of cos, which is secant. It will be root 2 over 1, which is just root 2. And for cotangent, the reciprocal of 1 for tan is also 1. So that is our isosceles 45 degree right triangle. The next triangle we have is an equilateral triangle where all 3 sides are equal to each other. And because it's an equilateral triangle, all 3 angles are equal to 60 degrees. Now, in order for us to create a right triangle, which is important for our special triangles, we cut the equilateral triangle in half, so then we have 2 right triangles. I'm just going to focus on the one on the left. So this bottom angle is 60, and because I cut the top angle in half over here, this angle is now 30, and here's our 90 degree. Now again, we have the freedom to choose all 3 of these equal sides, and I'm going to pick 2. And the reason I'm picking 2, because this base, that is 2, when I cut it in half, each side length in the little triangles will be 1. I don't want to use 1 because then I cut it in half and I get 0.5, and I don't want to deal with that. So now, the only side that is missing is this height of my triangle. It's not the hypotenuse, so I am going to use Pythagorean theorem, but the rearranged version. So I'm looking for the height. So my Pythagorean theorem will look like 1 squared plus x squared equals 2 squared. So x squared is equal to 2 squared is 4, and when I bring 1 squared over, it's going to be minus 1. X squared is equal to 3. Square root both sides, and we get plus or minus root 3. But again, it's a triangle length, so we're going to use the positive version. So here we are. 1 for the base, 2 for the hypotenuse, and root 3 for that height. Now, if you ever forget what the radical is, again, you have the freedom to choose what all three sides are equal to, and then you're using Pythagorean theorem. So from this triangle, we can figure out the 6 trig ratios for the 30 and the 60 triangle. I'm going to start off with the 60 triangle, and I'm going to label root 3 as opposite, 1 as adjacent, and the 2 is the hypotenuse. So sine 60 is opposite over hypotenuse, so root 3 over 2, and that is fine. Cos 60 is adjacent over hypotenuse, so that is 1/2. Tan 60 is opposite over adjacent, so root 3 over 1, which is just root 3. And now let's take our reciprocals. For cosecant, I'm taking the reciprocal of sine, so that would be 2 over root 3. I'm not happy with the radical in the denominator, so I'm going to multiply top and bottom by root 3. So the numerator will be 2 root 3, and the denominator will be that nice whole number of 3. For secant, I'm taking the reciprocal of cos, so the reciprocal of 1/2, which is 2 over 1, or 2. And for cotangent, I'm taking the reciprocal of root 3 over 1, so 1 over root 3. And again, I need to rationalize that denominator, so I'm going to multiply the numerator by root 3 and the denominator by root 3 to get just 3. And there is our 60 trig ratios. And now let's do the 30s. So I'm going to use a different color. I'm going to use green. Opposite is now the 1. Root 3 is now adjacent, and the hypotenuse is still 2. So now I'm going to base all of my trig ratios based on the green highlight. So sine 30 is going to be opposite over hypotenuse, which is 1 over 2. Cos of 30 is going to be adjacent over hypotenuse, so root 3 over 2. Tangent is going to be opposite over adjacent, 1 over root 3, which I need to rationalize. So I multiply the top by root 3 and the bottom by root 3 to get 3. And now I'll take my reciprocals. The reciprocal of sine of 1/2 is 2. The reciprocal of cos, or root 3 over 2, is 2 over root 3. And again, multiply top and bottom by root 3. And for cotangent, I'm going to take the reciprocal of the unrationalized version, so that when I take the reciprocal, the radical will go up in the numerator, so that I get root 3 over 1, which is just root 3. Now these are the main angles, 30, 45, and 60. They are the ones that you will see most often. Now there is an imaginary triangle that has 0 and 90 as well. When you start graphing sine and cos, you really don't use this triangle anymore, but for now, we will look at it. So this is an imaginary triangle because you can't actually have an angle of 0, but here we have our right angle. The angle to the right is 90 because it's just stuck on, and this top one is 0, so it doesn't actually exist. But we are going to label our sides. So this side is 1, this side is 1 because they are actually stuck to each other, making this side 0. Because again, you see a triangle, but it's actually just a straight line. Now, let's go ahead and do these ratios. And I'm going to start by using the 0. So then I have 0 as opposite, 1 as adjacent, and 1 as the hypotenuse. So sine of 0 is going to be opposite over hypotenuse, so 0 over 1, and 0 divided by 1 is 0. Cos is going to be adjacent over hypotenuse, which is 1 over 1, or 1. Tan is going to be opposite over adjacent, which is 0 over 1, which is 0. Now, for my reciprocals, I have to be careful. When I take the inverse, or the reciprocal of 0 over 1, I get 1 over 0 for cosecant. You can't divide by 0. So cosecant of 0 is undefined. For secant, the reciprocal of 1 is 1, And for tangent, again, I'm taking the reciprocal of 0 over 1. So cotangent of 0 is undefined as well. And now finally, we just have to do our 90. So I'm going to use green for 90. Opposite is now 1. Adjacent is 0. The hypotenuse is still 1 as well. So sine of 90. Opposite over hypotenuse is 1. Cos of 90. Adjacent over hypotenuse is 0 over 1, which is 0. Tangent of 90. Opposite over adjacent, which is 1 over 0. That is undefined. Now let's take the reciprocals. The reciprocal of 1 is 1 for cosecant. The reciprocal of 0 over 1 is 1 over 0, so that is undefined for secant. And for cotangent, I'm taking an undefined ratio, 1 over 0. Take the reciprocal, we get 0 over 1, which is 0. So that one actually exists. So these are all of your trig ratios for the special angles. This chart is not something that you need to memorize. I filled in the chart using the triangles to show you how to find the ratios, but not how to memorize it. What you need to know is how to create the triangles on your own. Know that you have a 45 isosceles triangle, a 30-60 equilateral triangle, and that imaginary 0-90. And if you can just draw your triangles, you can come up with these ratios on the spot. So I'm just going to show you how easy it is to draw these triangles on the spot. So I'm going to start with the 45. I'm going to draw a right triangle. Both of these angles are 45 degrees. And I know these sides are equal, so I'm going to choose 1 and 1. And if I remember the hypotenuse is root 2, great. And if you forget it, you can do Pythagorean theorem. There's one triangle done. The next one is the equilateral triangle that we've cut in half. So we know this is 60 and the angle that was cut in half is now 30. The sides that are equal are all going to be 2. The side that is split in half, each side is 1. If you remember that the height is root 3, great. And if you don't, you can do Pythagorean theorem and do 1 squared plus x squared equals 2 squared, solve for x. And our final triangle is that invisible imaginary triangle where this top angle is 0 and you have two 90s on the bottom. So your side lengths 1, 1, and 0. And that's how quick it is to draw all three triangles, and now you can come up with any ratios you want.